Alright, here's a quick video. Going to run through your different types of functions, and then we'll hit domain and range. I'll create a second video, or maybe a third video to cover the other two topics for this section. These are basically called our parent functions. Let's call them our parent graphs, because each of them aren't necessarily parent functions. So the first one would be the equation y equals x, and this would be called a linear. Obviously, this is the graph that has no transformations. It's the original. There's no changes to it, no transformations. The second one, kind of out of order here, but gives us the basic idea. It would be the cube root of x, and so this would be called a cube root function. That's two O's right there. So what I would be doing right now if I were you as a student is I'd be copying these down and just kind of drawing sketches. If I get going too fast, just hit pause and then hit play when you're ready again. So we got y equals x cubed, and this would be called a cubic. We roll over here, this would be y equals x squared. This is called a parabola, or a quadratic. Alright, so a quadratic creates a graph called the parabola. This guy right here would be y equals the square root of x, and so it would be a square root function. Oops, we don't want the word function on there, sorry. Nothing wrong with calling it a function, but just want to be careful about this. This guy right here would be x squared, excuse me. How about not x squared, but how about x equals y squared? So it's essentially like a square root function, except it has both the positive portion of the graph and the negative portion, whereas right here you only have the positive portion of the graph. This guy right here would be y equals the absolute value of x, and so this would be called an absolute value function. Now, I didn't give this guy a name right here because really it's not a function, so obviously it doesn't really have a special name, so it's just kind of this special characteristic. And like I said, it's looking at both the positive and the negative. Alright, so that kind of runs through the different types of graphs. Let's go back and take a look at the domain and range. So when we come through here, remember that our domain is our x values. So when we look at this graph here, remember this arrow keeps going. So as we cruise along in the negative x direction, so starting at the origin and we cruise out here towards negative infinity, and we start at the origin and we cruise out here towards positive infinity, the question is are there any x's that don't work? And the answer is, well, no. You can plug in any x. So in this case here, my domain is negative infinity to positive infinity, which is also known as all real numbers. Our range corresponds with our y value. So our range is looking up and down. So in this case here, we're starting at the origin and we're saying, yeah, that's fine, we'll do it. I like to think about it this way. I like to start from negative infinity and say, come up this way towards the origin, and I'm covering everybody. Like, you know, if I plug in -2 for x, I get a -2 out for y. If I plug in a -5 for x, I get a negative value out for y. So this line goes on forever. So it starts at negative infinity, and it goes, well, if I keep on going up towards positive infinity, yes, my graph will keep on going up, up, up. And as it's going out, it's also coming up. And so it would be positive infinity. Alright, so when we come take a look at the next ones, and we start looking about the domain and range, the domain, get the right color. The domain for this guy, once again, is my x values. So since this arrow goes out forever, and since this arrow right here goes out forever, then our domain is going to be negative infinity to positive infinity. Our range doesn't climb quite as fast. It doesn't go up as quickly. Like on this graph, we went up pretty quickly and kept going up and up and up. On this one right here, it looks like it levels out, but over time, it still continues to go up. It just takes a long time to get there. Same thing with this cube root function right here, or the cubic function, excuse me. My domain same deal, negative infinity to positive infinity. And my range, in this case, same deal, negative infinity to positive infinity, because this arrow points down forever, and that arrow points up forever. So just like the domain and the range on the others, there's no limits on what's going on. So we're actually going to see some limits on this page. So come into the domain. When we look at the domain of a quadratic, the domain of a quadratic is all real numbers. And the reason is because as this graph is going up, yes, it's going up, but it's also coming out. So it's going to continue to be able to plug in x value, negative x values that will give me y values out. I'll be able to continue to plug in y values, or excuse me, positive x values that will give me y values out also, because this graph goes up over here. So my domain will be all reals. However, my range will have limits, and that my range does not come below 0. Like, I don't come down into this area of the graph. So my range will start at 0, including 0, so I use the bracket because that's actually an ordered pair right there, and that ordered pair is 0, 0. So my first y value that I use is 0, and my graphs keep on going. Even though they're not on the y-axis, they're both going up towards positive infinity. On the second graph, here, once again, we have some limits. So we discuss our domain, and our domain has limits. And our domain starts at 0 and goes to infinity. And the reason is because this point right here, which is 0, 0, looking at my domain, my first domain value that I acquire is 0. And I'm actually touching it and I'm using it, and that's why I have the bracket to include it. My range will once again start at 0 and go to infinity like it did on this previous one, because once again we start here at this point right here. There's our first y value, we're including it, so we use the bracket, and we go, even though it's going out, it's also coming up, so we have from 0 to positive infinity. Here, the domain on this guy, so once again, starts at 0 and goes to infinity, because we look right here, we're looking at x's, so we're looking side to side. This would be negative infinity on the x, this is positive infinity on the x. And we start at 0, 0. So we start here, and we cruise along right here. And we have y values that come out on both sides, but the point is that these are all the x's that are used in my graph. My range, well, remember, range goes from top to bottom. So this guy means that he's going to come down forever and ever and ever. This guy's going to go up forever and ever and ever. Even though they're going out quicker, they're actually going up and down also. So my range for this guy will be negative infinity to positive infinity. Last one, my domain. So once again, you take a look at this graph. We think about the domain as the x-axis. So we think about from negative infinity on over. And since this graph, once again, is coming out but also going up, we come from negative infinity to positive infinity. And for my range, I start right here. So remember, range comes from the bottom and goes to the top. So my first point that I touch is right there, which is 0, 0. So that means that I'm actually looking at that y value right there. So my range will start at 0 and go to infinity. Okay, so that knocks out kind of talking about the different types of functions and then their characteristics with domain and range.